Okay, welcome to virtual chemistry. Today we're going to do a little bit of review / practice ionic compound naming. So to get there, what we need to review is the idea of charge. And this concept is very important, so you have to learn it now or it will haunt you later. I kid you not. It's never going to go away, so we got to get good at this right now because it'll make your life easier later. So what we started to do this week is we started to learn how to read the periodic table, which is really important because the better you are at reading this thing, that means the less you're going to have to memorize. So let's just learn how to read it instead. We'll learn how to count it. So first thing to do some quick review of is that the atoms are arranged from increasing atomic number. The atomic number tells us the amount of protons. And if we have a neutral atom, which all atoms are neutral, then it tells us the same amount of electrons. So what that means is any atom has the same number of protons and electrons, and that's what our atomic number tells us. What we also talked about is the atoms are arranged from periods and groups. So the columns, 1 through 18, 1, 2, 3, blah, 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 those are your groups. The rows, these are your periods. And so I gave you special names for 2 of the groups. I gave you special names for 4 of them, but we really just care about 2 of them. So for example, group 17 are your halogens. Fancy word, you're gonna hear me say it all the time. More importantly for today's lesson, group 18 are your noble gases. So let's talk about the noble gases. The noble gases are very important because these atoms are unreactive. So let's think about it. The reason atoms react is so that they can get stability. So the noble gases, they don't react, which means they have the perfect stability that everyone else wants. So what that means practically for us, and we'll learn why they don't react a little bit later, very soon, but the reason they don't react will come. So what that means is because they are so stable, all of these other atoms to the left of them, which is everyone else, wants to be a noble gas. They are the bee's knees. So what we're going to talk about today is how atoms become noble gases. So atoms are defined by their number of protons, which is their atomic number. Coincidentally, the number of protons and the number of electrons match, so we can read the amount of electrons each atom has as an atom. So because they're defined by their protons, they're not going to gain and lose protons. And we're not talking nuclear chemistry here, so the number of protons is going to stay the same. But the way that they can become like the noble gases while still being themselves is by gaining and losing electrons. So today we are talking about electrons. So what we started to do is we started to predict the most stable charge. And so for an atom to become stable, it's to become like the noble gases. So we are going to manipulate electrons to be like the noble gases. What do I mean by that? Well, this is when we were predicting some charges. So for example, let's predict the most stable charge for phosphorus. All right, so we're going to predict the most stable charge for phosphorus. So all that means is we need our periodic table and we need to be able to count. So your first step is to find phosphorus on the periodic table. And so phosphorus is a nonmetal, it's to the right of the staircase. So phosphorus is right here, so we're going to draw the symbol for phosphorus, which is P, which you guys should have memorized because we're going to have an element quiz on Monday. And it's going to be the first 20 elements on the periodic table. You should know their atomic symbol and their atomic name. Anyway, we'll proceed. So your first step, you're going to write phosphorus, and then above it, you're going to write the amount of electrons that the atom of phosphorus has. In our case, it's 15. And now you want to look at the noble gas column. And you want to find the noble gas that is closest to phosphorus. So you either have argon, which is 18, or neon, which is 10. And so the number 18 is closer to the number 15, which tells us phosphorus is going to act like argon. So how do we make phosphorus act like argon? Well, what we're going to do next is we're going to write the symbol for argon, and we're going to write the amount of electrons that it has. So looking between 15 and 18, we got to figure out what does phosphorus need to do to become 18? Easy math. What phosphorus needs to do is it needs to gain 3 electrons. E minus is just the symbol for electrons. I'm lazy, so I'm just going to write the symbol instead of the word. So phosphorus needs to gain 3 electrons. So this is where we got to use logic. If you are gaining 3 electrons, what is your charge going to be? Let's think about it. The charge of 1 electron is -1. So if I'm gaining 3 negative things, that means my charge is going to be -3. So the way we write the most stable charge for phosphorus is P -3 in the top right corner. So that's a review of that concept. But what scientists realize is there's a trend. So what we're going to do is we're going to label the trend on the periodic table if we haven't already. What you can do is, for the most part, you can count and figure out what the most stable charge for each atom is going to be. So what we're going to do is we're going to start with the noble gases. We know that the noble gases don't react, so they're going to be 0. So you're going to put a 0 on top of the noble gases if you haven't already. And then we're going to count down from 0. So we're going to go -1, -2, -3, and stop. What scientists realize is the most stable charge for these 4 groups is just simple counting. You go 0, -1, -2, -3. And so that means for anyone in this column, they're going to have this charge up here. So for example, if I ask you what the charge of bromine is, you no longer have to do what we did earlier. You can just look, find bromine, and read it's going to be -1. All of your halogens are going to have a charge of -1. Very convenient, but what about the other atoms? So what we're going to do now is we're going to start at group 1. And you're going to hear me say this all the time. The trend for group 1 plus 1. And we're going to count up from there. 1, 2. So group 1's +1, group 2's +2. Now we have something called the transition metals. So from scandium to zinc, we're just going to skip it. From 3 to 12, we're going to skip those columns. Transition metals are special. They have multiple charges. They don't follow a specific trend. And now we're at group 13. Group 13's boron. So we're going to count up from group 2. So we have +1, +2, +3. And so now we just figured out all the charges for these atoms, the charges for these atoms, the charges for these atoms, these, and these. So now we know what the charges are. And because we know what the charges are, now we can start writing ionic compound formulas.